Right, question 6. So this is the particles question. We've got some background information about helium and beta decay and something about an anti-helium and a helium nucleus which are hitting each other. First question though, dead easy. What is meant by an isotope? So standard book learning question. You should have learned this in GCSE. And isotopes are atoms or nuclei with the same number of protons but a differing number of neutrons. Okay, same number of protons, different numbers of neutrons, that's isotope. Explain why two photons are formed instead of a single photon when a helium nucleus annihilates with an anti-helium. Okay, so this is a little bit subtle, but if we have a helium coming in here and we have an anti-helium coming in this way, they annihilate each other. If they were to send off just one gamma photon like that, then you've got the momentum of these two heliums. Well, if they're going straight at each other, the combined momentum of those is 0. But photons actually have momentum, so that photon going off there has momentum. Momentum has to be conserved. So if where did that momentum come from? Well, it can't come from anywhere. If the initial momentum is 0, the final momentum must be 0. So we must have something to balance the momentum of that gamma. So we need a second gamma coming this way. So the energy splits between these two gammas in order to conserve momentum. So first of all, the rule, momentum must be conserved. So if one photon comes out one way, a second photon must travel in the opposite direction to cancel out the first's momentum. As a bit of a side, if the heliums were moving like this, so we had the helium there, your anti-helium there, and then they hit, then they would have a net momentum forwards. So your gamma rays would go that way and that way, because then their momentum in this direction is 0, but their momentum in that direction exists, which has to be equal to the original momentum of the heliums there. Right, calculate using data from the passage the maximum frequency of the photons produced in the annihilation. Okay, so this is the second mistake on the paper. It's a bit more subtle and doesn't affect students. Most students, I don't think, would ever have spotted it. But that word there should read minimum, because if the particles are moving like this, then that means they've got more energy. So the gamma rays will have more energy, which means that the photons will have a higher frequency. But that one is a second mistake to slip through the net. So anyway, right, the rest energy is 3728 mega electron volts. Now we've got to remember that we have two of those. We've got the helium and we've got the anti-helium. So the total energy is equal to 2 times by 3728 mega electron volts. But we've also got 2 gamma photons. So the energy of each gamma is equal to the total energy, 2 times 3728 mega electron volts, divided by 2. So lo and behold, those two cancel, and each of these gamma photons has the same energy as one of these heliums that they started with. So we can just work it out like so. So we need E is equal to HF, so F is equal to E divided by H, so that's the energy of a photon equation there, which is located on your formula sheet right now. Okay, so now we need to just put in our values. So F is equal to, right, we need the energy, so that's 3,728 mega electron volts, so we need to times by 10 to the 6 to change it into electron volts, and then we need to times by 1.6 times 10 to the minus 19 to change it into joules. And then we need to divide that by H, which is on the formula sheet, Planck's constant, so that's 6.63 times 10 to the minus 34, like so. So let's have a look at that. So we've got 3,728 times 10 to the 6 times by 1.6 times 10 to the minus 19. So that's the top line divided by 6.63 times 10 to the minus that there. So 8.99668 dot 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 times 10 to the 23 hertz. Right, let's have a look at sig figs. That's to 4 sig figs. That's to 3 sig figs from the formula sheet, so we can write the answer to 3 sig figs. So that's 9.00 times 10 to the 23 3SF. Okay, complete the following equation for a possible decay of an anti-neutron. So just think about balancing it. We started with one baryon, we've ended with a baryon, so that's okay. We started with one mass, we've ended with one mass, so we want something that doesn't have a mass here. We started with a charge of nothing, we've ended with a minus charge, so we have to balance charge, so we want a +1 charge there. That particle you should know with one charge and a little mass is an anti-electron, so that's a beta plus particle or an electron bar like that. But we also need to balance lepton number, so we've got baryon number as balanced because we started with an antibaryon, ended with an antibaryon. We have here an antiparticle, so we need a particle here, and it's got to have no charge, so it's got to be the neutrino. It's the electron neutrino, and it's the particle version because particle there, antiparticle there. And then this is book learning. You should know that that interaction is a weak interaction. And that's the end of that paper. Well, I hope that helped. You can ask me questions below. I'll try and respond to them. And good luck in your exams. Thank you very much for listening.